In 2017, astronomers discovered Oumuamua, the first interstellar object in our solar system. Now the NASA ESA Hubble Space Telescope has found that it is leaving our solar system faster than expected.
The first time we discussed it, we were saying, oh my God, we really need to check and double check and make really sure, because the effect is so small and so subtle that many things could go and screw up your measurements. And after checking and double checking and cross checking, the effect was still there.
But astronomers might have already found an intriguing explanation to this observation. Oumuamua first came to the attention of astronomers by the end of 2017. Observatories around the world discovered that the object was a lonely voyager from interstellar space, the first of its kind to be observed.
So for the first time, we had evidence of an asteroid, an object that was coming at a very high velocity into our solar system, and the velocity was so high that it proved that the object was actually coming from the outside. It was coming probably from an other solar system and was just passing into our system.
Astronomers using Hubble and other observatories to study it in more detail have now found something odd. This peculiar object is moving faster than the laws of celestial mechanics predict. A result that caught the scientists by surprise.
We considered really various. One of them is an interaction with some magnetic field, or another one would be an interaction with a force going along the trajectory, not really knowing what it would be, just to see if it works, or a force that would be an impulse, like a small outburst or things like that. And all these hypotheses fail.
The most likely explanation for Oumuamua's odd behavior is that it is outgassing. Outgassing occurs when sunlight heats up the surface of an object. This causes it to vent a plume of gas that acts like a booster rocket. However, outgassing is a typical behavior of comets, which now leads astronomers to suggest Oumuamua is an interstellar comet rather than an asteroid. However, Oumuamua shows no trace of typical cometary features. The interstellar visitor does not show a characteristic long tail of evaporating material. It also shows no evidence for a coma, an envelope of gas and dust surrounding most comets.
In terms of the quantity of dust and gas that is released, it's tiny. It's really not much, but it's very small, so you don't expect a lot of dust. And still, again, comparing with normal comets, it's about right for such a small comet to have so little gas.
Astronomers speculate that perhaps the small dust grains adorning the surface of most comets eroded during Oumuamua's journey through interstellar space, with only large dust grains remaining. A cloud of these larger particles would not be bright enough to be detected by Hubble. The true nature of this interstellar nomad may remain a mystery. Oumuamua's recently detected gain in speed makes it unlikely that we will be able to accurately trace its origin. And as it is getting further away from Earth, it becomes too distant for even the best telescopes in the world to observe.
We've never observed a comet like that before, but it's possible. We've never seen one, so many differences, many things in common, so we really need to wait for the next one to start making comparisons.
So the hope is that in the future, with better telescopes, more telescopes searching the sky for asteroids, we will find more of these objects.
But what we have learned from Oumuamua surprised us beyond our wildest imagination.
Now that you've caught up with Hubble, make sure to get the latest from the ground too. The ESOcast highlights the best of the European Southern Observatory and its powerful telescopes that observe from high in the Chilean Andes, at the Southern Hemisphere's best-known sites for astronomical observations.